Number 6. So we are asked to find all solutions between 0 and 2 pi. So seeing the 2 pi tells me I am in radians, and we are solving this equation. Remember, you do get a formula sheet on this test, so you don't have to have your formulas memorized. I saw 2 different approaches on this. A few people used a diagram identity to replace the secant squared, which definitely works. And some people just start out by bringing over this 2 tangent theta. So either option will get us there. Now when I look at it, I have 2 terms. What do they both have in it? Tangent. So it's just algebra. We're factoring, taking out the greatest common factor. Okay. So now at this point, we have 2 things multiplied that equal 0. So we set each one to 0. Right. Unit circles. You are welcome to use one on this test, but you have to fill it out. Okay, so you can't use one that's already filled out, but I will have blank ones if you need one. And if you choose to do that, you don't have to fill out the whole thing, just whatever helps you. If tangent is 0, so you can think about like the hand trick. We know tangent is the square root of the top over square root of the bottom. And we can think about the unit circle. Tangent is sine over cosine. So right here, sine over cosine, y over x, we get 0. What's the other time that's equal to 0? At 90, it would be undefined, right? 180. And 180 is the same as pi. So those are the 2 times that tangent is 0. If I'm solving this one, I mean secant squared is 2. To get rid of a square, you square root with that plus or minus. So secant could be positive or negative square root of 2. Now maybe it's just me, but I am much better with sines and cosines and tangents than I am with secant, cosecant, and cotangent. So I'd always choose to rewrite it, but that is up to you. Secant's a reciprocal of cosine, so that means cosine is 1 over this, or radical 2 over 2. If it can be positive or negative, which quadrants are we in? All of them can be in any quadrant. Okay, reference angle. When is cosine radical 2 over 2? 45 degrees. In radians, that's pi over 4. So pi over 4 in the first quadrant is pi over 4. In the second, the top is 1 less than the bottom. Third, top is 1 more than the bottom. And fourth, double minus 1 would be 7 pi over 4. Or you can use your unit circle at that point and find all of those. Is that okay with everyone? So, if I give you a question like that on your test, you know you get everything on the same side, take out your GCF and solve from there. All right, question number 7. Bless you. Okay, so this one, I have a sine squared, I have a sine, I have a 1. This is like a quadratic, isn't it? Any quadratic equation, you always set it equal to 0 to start. The only difference is instead of x, my variable is sine. So then what do we do? I bring down my 2. Right, multiply to negative 2 and add to positive 1, be a plus 2 and a minus 1. Don't forget to divide your 2 back. Are you guys with me there? So now if we set them equal to 0, we get sine to be -1 and +1/2. All right, sine is -1. You can think about hand trick or unit circle. Sine is the y. Y is -1 here. And what's that angle? $270, right? This is 90, 180, 270. But we were in radians, so we'll have to say 3 pi over 2. Okay, sine. When is sine positive? Two upper ones, 1 and 2. Reference angle. When is sine 1/2? 30 degrees, which is pi over 6. So pi over 6 in quadrant 1 is pi over 6. In quadrant 2, 5 pi over 6. All right. Is that one okay? So problem number 8. The thing that makes this one harder is we have two trig functions. There is no greatest common factor we can take out, and we can't just like slip and slide or anything because I have two trig functions. So what else can I do? Yes. Remember, we still have our formula sheet. Those Pythagorean identities. We had that first one, sine squared theta plus cosine squared theta equals 1. So that means I can replace my cosine squared with a 1 minus sine squared. So if I solve this, I can subtract my 1 over, that cancels. Add over my sine squared theta. If I divide, I get sine squared theta equals 0, which just means sine theta is equal to 0. So on the unit circle, sine is the y. Y is 0 here and here. So this is at 0 radians, or 2 pi. And this one is at pi. So those were all of our radian questions that you guys asked about. Let's look at some in degrees. So question number 13. Okay. This one is already ready to solve. If you're not comfortable with secant, you could rewrite it. That means cosine is what? Mm-hmm. 1 over the square root of 2 turns into radical 2 over 2. Okay, first of all, when we see a 2x, what does that tell us? Double solutions. Okay. Quadrants. When is cosine negative? Reference angle. When is cosine the square root of 2 over 2? So you can think about your hand trick or the unit circle. So that's 45 degrees. So my angle, which is 2x, could equal 45 degrees in quadrant 2, so 180 minus 45, or in quadrant 3, 180 plus 45. If I say double solutions, how do I get the second round? So if I add 360 we are trying to solve for x. So now we go through and we divide all of them by 2. So 135 divided by 2 is 67.5. 225 divided by 2 is 112.5. 495 divided by 2, 247.5 degrees. And 585 divided by 2, 292.5. And that's every answer between 0 and 360. Is that one okay? All right. So I need to solve for sine. First, let's get all of our sines together. So if I add over my sine of 2 theta, that's 5 sine of 2 theta. I can divide by 5. But I can't get rid of my angle. So when I see a 2 theta, that tells me double solutions. I know sine is positive in quadrants 1 and 2. But I do not know when sine is 2/5. So how do we find it? Sine inverse. So grab a calculator, make sure it's in degree mode, and then second sine for sine inverse 2/5. And I get 23.58 degrees. Did you guys all get that to work out? So, my angle, 2 theta, could equal, in quadrant 1, my angle is my reference angle. To get it in quadrant 2, you do 180 minus your reference angle. We want double solutions, so for the second round, we add 360. And to find our angle, we go through and we divide all of those by 2. Are there any other equation ones that we need to add to our list before we move on? So, questions 17 and 18. The directions say use law of sines or law of cosines. On your formula sheet that I've given you before, I don't know where my copy is right now, but the very back it has your law of sines, law of cosines. So those are all given to you. You're not memorizing them. We just have to be able to use them. And your directions on your test will be very similar in that I'll probably tell you, for these questions, use law of sines or law of cosines. So you just have to be able to pick out which one you need. So in problem 17, I know angle A, side A, and side B. Not that I couldn't use either one, but law of cosines is more set up where we can easily find a side. Law of sines works well when you have an angle side pair. Because remember, law of sines was A over the sine of A equals B over the sine of B equals the C over sine of So since I have both angle A and side A, this would probably be the route to go. The other one I'm looking for is B, so I'm going to use this ratio. So A, 9.72, for the sine of 38 degrees, 40 minutes, equals B, 11.8, over the sine of B. So if we cross multiply, then we can divide the 9.72. All right, everybody type that in. Make sure you remember how to put in your degrees and minutes. Zach, you might need a calculator if you're going to plug it in. Did you guys get 0.75849? Here's why it said two possible values for B. We know that sine is positive in both quadrants 1 and 2. To get my reference angle, we have to do sine inverse, so second sine, 0.75849. So then, in quadrant 1, that would be our angle. In quadrant 2, you have to do 180 minus that, and you get the 130.67 degrees. So those were the two possibilities there. Question number 18. We know angle C is 28.3 degrees. Side B is 5.71 inches. And side A is 4.21 inches. We are looking for side C. So you could try law of sines, but as soon as you plug in, you notice a big problem. We don't have a complete set. We don't have an angle and a side pair. So law of sines is not helpful to me. So then when I go to my formula sheet and I'm looking, law of cosines, there's 3 versions. So since I'm looking for C, I would probably pick the one that's C squared equals A squared plus B squared minus 2AB cosine of C. Okay, if you want to get rid of the square, what would you have to do? And then we can plug in. A is 4.21 squared. B, 5.71 squared. Times 2 times A times B cosine of C. And now it's just a matter of putting that in your calculator. So everybody try it. So, y equals arctan of 1. First of all, tangent inverse can exist in which quadrants? 1 and 4. If it's positive, you're in quadrant 1. So we're just asking ourselves, when is tangent equal to 1? In quadrant 1. And what's our angle? I didn't specify degrees or radians on this. So 45 degrees, if you put pi over 4, that's also correct. All right, number 2, arc sine. In which quadrants does sine inverse exist?
1 and 4.
If it's a negative, we're quadrant 4. Okay, reference angle. When is sine 1/2? So 30 degrees in quadrant 4, so 360 minus 30, 330 degrees. All right, number 3, cosine inverse exists in which quadrants? 1 and 2. If it's negative, we're in quadrant 2. Reference angle. When is cosine radical 2 over 2? So 45 degrees in quadrant 2, 180 minus 45 is 1. All right, how do we do on 1 through 3? Okay. Then, solving. So this one, now that I changed your problem. What can you take out? Okay. So if we set those equal to 0, when is sine equal to 0? Okay, this is saying cosine squared is equal to 2, which means cosine is plus and minus the square root of 2. Can that happen? No, that's bigger than 1. Cosine can only be things between -1 and 1. So 0 and pi are the only answers here. All right, number 5, we can get our cotangent by itself. Okay, if cotangent is -1 over the square root of 3, that means tangent is the reciprocal, which is just negative radical 3. In which quadrants is tangent negative? 2 and 4. Reference angle. When is tangent the square root of 3? 60 degrees. So 60 degrees in quadrant 2, so 180 minus 60. 120. Quadrant 4, 360 minus 60 is 300. All right, how did those go? Good? Okay, let's try maybe 2 more. Let's do degrees on this. So walk me through it. What do we do on the first one? Okay, quadrants. When is cosine negative? Reference angle. When is cosine the square root of 3 over 2? 30 degrees. Okay, so what does the 3x tell me? So my angle, 3x, can equal, in quadrant 2, 180 minus 30 is 150. Quadrant 3, 180 plus 30 is 210. How do I get my triple solution? Add 360 to both, so we get 5 to 10, 70. Okay, that's double, so now we have to do it again. Okay, now to get x, we just divide all of those by 3. Is that one okay? And then question number 7. When is cosine negative? Reference angle. I do not know when cosine is 1/3. So that means we use our calculator. Do cosine inverse of a positive 1/3. So my angle, which is x over 2, could equal, in quadrant 2, we have to do 180 minus that. In quadrant 3, we do 180 plus that. And then to get x, multiply by 2. Now, both of these are solutions, but my directions did say to give the solutions between 0 and 360 degrees. So we don't have to include the second one. The first one's the only one in the interval I want. All right, we only have about 3 minutes left. Law of sines and cosines, the directions will specifically say to use them. The formulas are given. Do you guys feel like you can handle that then? And then we did not ask any questions about the vectors. But remember, magnitude and direction, those formulas are on your formula sheet. Writing the formula for a vector, that's on there as well. So you just have to be able to use those formulas to apply.